Today we are exploring one of the key concepts in hypothesis testing: how to formulate the null and alternative hypotheses for both one- and two-tailed tests. The null hypothesis is the starting point. It assumes there is no effect, no difference, and no meaningful relationship between the studied variables. In other words, it suggests that any changes we observe are simply due to chance or natural variation and not the result of treatment or condition we are testing. The alternative hypothesis is the one we are aiming to provide support for. It challenges the assumption of no effect and proposes that something is truly happening as a result of a change in experimental condition. The two-tailed test is used when we open to detect a difference in either direction, whether the outcome is higher or lower, better or worse, more or less. This means that we are testing for the possibility of an effect in either direction without assuming which way it may go. Let's look at some examples. Imagine a researcher that wants to compare the effectiveness of two different medications. In this scenario, the null hypothesis assumes there is no difference between these two medications. The alternative hypothesis doesn't specify which medication is better, just says they are not the same. Here's another example. A business analyst wants to know if average customer spending is the same across 5 different store locations. He formulates the null hypothesis: there is no difference in average spending across all locations, and the alternative one, that for at least some of the locations we observe the difference in average spending. We are not predicting which store records higher or lower spending. We are just testing whether any difference exists. Rejection of the null hypothesis would not specify whether the difference is between all stores or just some of them. A one-tailed test is used when a researcher has a specific direction in mind for the expected effect. Let's look at the example. A researcher is testing whether a new medication improves patients' outcome. We have the null hypothesis: the new medication doesn't improve the patient's condition, and the alternative hypothesis: the new medication does improve the patient condition. This is one-tailed test. We are only interested in improvement, not whether the medication makes things worse. Let's look at one more example. A researcher wants to know if stress levels are higher in people working the night shift compared to those working typical daytime hours. The null hypothesis: there is no difference in stress level between the two groups, and the alternative one: stress levels are higher in people working the night shift. Again, this is a directional hypothesis. We are specifically testing whether stress is higher, not just different. This is one-tailed test.